Okay, the next two problems I have opted to use the calculator for. It is possible to do this one by hand, but it would be an awful pain. So let's not, and say we did. And I'm also going to use the calculator for this. Again, we could do it by hand, but it's also important to learn how to use your graphing calculator, because in the real world, we have calculators. All right, so what we're going to do here is we are going to find the slope of the tangent line at x equals 1. So to do that, we need to take the derivative of this. So we need to take dy dx, and we need to then plug in x is 1 to get the slope. Okay, so we need to find the derivative. So we need to find y prime and evaluate at x equals 1. Okay, so I'm writing down what I'm going to do because I kind of just am going to do it. So I'm going to plug it in here. So I'm going to have parentheses 2 minus 3x squared times, oh, and that's to the third, raised to the third power, times 2x squared minus x plus 1, and that is squared. Let me make sure I wrote it down right, because I'm really good at messing things up. 2 minus 3x squared to the third power, 2x squared minus x plus 1 squared. Looks good. So if I graph it, it doesn't really matter what the graph looks like. As long as I can see x equals 1, I should be fine. Now I'm going to go to the Calculate menu. Oops, as soon as it's done graphing. Go to the Calculate menu, and I want to know the derivative. That's number 6, because that'll give me the slope of the tangent line. The derivative is the slope of the tangent line. Number 6, and I want it when x equals 1. So I'm just going to type a 1 and hit Enter. And it tells me the slope is negative 84.00302. So the slope at x equals 1 is that slope, the slope of the tangent is equal to negative 84.0, because we rounded off to 3 significant figures. Okay, the equation of the tangent line. All right, so that's going to be y equals mx plus b. So I have my slope, negative 84.0 x plus b. But now I need an x and a y in order to plug them in to solve for the y-intercept. So to do this, I already have an x. I know x is 1, but I don't know what y is. To get y, I'm going to plug in y into the original equation. Well, I already have that equation in my calculator. It's right there. So all I have to do is, again, use the Calculate menu. And this time I'm going to choose value. I want to know what is y when x is 1. So I'm going to choose the value option, and I'm going to type 1, and it'll tell me what y is. It says y is negative 4. So, negative 4. So I could have done this by hand. I could have plugged in 1 for the x's and then evaluated it, but the calculator is so much faster. So that is my x and my y. So I'm going to put in negative 4 is equal to negative 84.0 times 1 plus b. And that's super easy to multiply out. Negative 4 is equal to negative 84 plus b. Add 84 to both sides. And I get 80 is equal to b. So therefore, my equation of my tangent line is y is equal to negative 84x plus 80. And we could even check it. I can get my graphing calculator, and I can put in that equation, negative 84x plus 80. And if I graph it, we should, what did I do wrong? Oh, I used the wrong negative sign. There we go. Okay. It should show me a line, thinking about it. There it is. That's really weird looking. Did I enter it in right? Let's see, zoom 6. That was really strange. I'm waiting. There it is. Okay. So my window was set in a very strange way. So there it is. It's practically vertical, okay? A slope of negative 84, that's over 1, down 84. So that's an incredibly vertical type line. So, yep, looks good. All right, and it looks like it's tangent to the curve. Okay, next question. Again, we're going to use our calculator for this. We could do it by hand by using the chain and the quotient rule, and then entering in x equals pi. But then the part with the round to 3 decimal places, that I can only do with my graphing calculator. I'm not going to be rounding to 3 decimal places by hand. That would be insane. So find the gradient of the tangent to the graph of g at x equals pi. So exact same thing that we just did here, except they're using the word gradient instead of slope. But gradient, of course, means slope. So all we need to do is find g prime of pi. So we're going to do this on the graphing calculator, and we're going to round it to 3 decimal places. All right, so here we go. So I'm going to put in my new equation. Glare off of that. The equation is tangent of 2x divided by x squared. Graph that. That's cool. Looks like a heartbeat. Somebody having a heart attack. Holy cow. All right. Gosh, that is insane. I hope I put that in right. All right, so now I'm going to go calculate, and I want the derivative, which is 6. Number 6 here, so that one. And I want to know at pi. Well, pi is right here on my calculator, so I had to hit second to get the pi. So don't put in 3.14, actually put in pi. And I get 0.203. And I use my graphing display calculator. Actually, I should have put that up here. Graphing display calculator to get that answer. How did I get it? I used my calculator. Okay, that's that. Next one, the diagram. This one's a no calculator. The diagram shows part of the graph of the curve with the equation, blah, blah, blah. Show that the derivative is equal to this. Okay, so this derivative, I see that I have 2 functions being multiplied together. I have e to the 2x, which I'm going to have to use the chain rule on, times cosine x. So my u is going to be e to the 2x. The derivative of that is e to the 2x times the derivative of 2x. The derivative of 2x is 2. So there's that. Okay, and then the other function, v, is cosine of x. The derivative of cosine of x is negative sine of x. Now we're going to crisscross applesauce. So I'm going to have 2 e to the 2x times cosine x plus e to the 2x times negative sine of x. I can move that negative sign to the front. I can also factor out the e to the 2x, but it's not, oh yeah, it is required in order to get that. So when I rewrite this, I'm going to factor out my e to the 2x, and I'm going to be left with 2 cosine x minus sine of x. Or I could have put plus a negative sine of x, but this matches what I'm supposed to get anyway, so there it is. All right, and then we want to find the second derivative. So I have this, and again, this is a, how am I going to do this? This, I'm going to use the product rule again. I have this one times this one. So u is equal to e to the 2x. And we know the derivative of that. That's equal to 2 e to the 2x. This down. Then I have my v is equal to 2 cosine x minus sine x. The derivative of that is equal to 2 times negative sine. So I'm going to put my negative out there. Minus the derivative of sine is cosine. And now I can crisscross applesauce. And I'm going to do this one first. So I have 2 e to the 2x times 2 cosine x, oh, and this is in parentheses, minus sine x, okay, because it's times all of this. So let's put that one in parentheses also. Plus e to the 2x times negative 2 sine x minus cosine x. And I suppose we could rearrange that a little bit. So I'm going to pull out my e to the 2x's like we did before. So I have e to the 2x times 2 times 2 cosine x minus sine x plus negative 2 sine x minus cosine x. Okay, and now I could distribute. This is going to be handy, actually. Let's see, what did I do? Actually, I'm looking at my original answer key, and I just realized I made an error. Okay, so anyway, let's keep going over here. I'm running out of room. Shoot. Let me get another piece of paper. Because I can simplify this some more. So I have e to the 2x times 2 times 2 is 4 cosine x minus 2 sine x. And then this one, I can just drop everything. Did I make a mistake? Did I put a 2 somewhere that I didn't need it? No, I'm doing okay. I think. Minus 2. If anybody notices that I made an error, please just email me and let me know. Okay, so I dropped my parentheses on that one. Now, do I have like terms? Yes, I do. I have that one and that one. So I have e to the 2x. 4 minus 1 is 3. And negative 2 sine x minus 2 sine x is negative 4 sine x. And I think that should do it. Let me see if I made any errors here. That looks okay. That looks okay. Then when I multiplied them, 2 e to the 2x, I took out my e to the 2x, that left me with that. And I have to distribute it, 4 minus 2, and that left me with that and that. Yeah, I think I'm okay. All right, so that simplifies down. Final answer, I'll write it on here. E to the 2x times 3 cosine x minus 4 sine x. Bam. All right, that's page 2.